So hello friends, today at Code Catalog we'll be studying about linked list, its basic concept and traversal in C and C++. So the first question which arises is, what is a linked list? So a linked list is a set of data elements of same type, each containing a link to its successor, also sometimes its predecessor. By saying the same type, I don't mean that it should have the same data type, but if we consider the information of one student in some database as a structure, then all the nodes of that linked list should be of the same student structure. So that's how a node looks like. The bigger rectangle is representing the information part and the smaller rectangle is the link part. So we'll be more clear of the structure in the next portion of our video. So that's how a linked list looks like. It has one head which represents the starting of the linked list and a null point which represents the end of the linked list. So we'll be using these two concepts in traversing our linked list, which is the starting, that is the head, and whenever any node has its link as null, that would represent the end of a linked list. So this traversal can be used in insertion, deletion, or any kind of operation on linked list. We'll be covering these operations in our next videos. So coming to the structure of a student, we'll be considering this structure as a node. The structure would have an admission number, a name, then marks, then the node star link, which is the self-referential structure. A self-referential structure is a structure which has a pointer which contains the address of a similar kind of structure. So this would be the link portion which will contain the address of the next nodes. So that's how a node would look like. Admission number, name and marks would be the bigger rectangle and link would be the smaller rectangle which has the link. If this link was null, it means either the linked list has come to the end or the list has only one element. So let's look up to the syntax of C and C++ both. So coming to the first condition, which says that if start was null. So this makes it very clear that start would be a global declaration which we'll be including in our programs, since the start would be used for traversal in any kind of function which can be either insertion or deletion. So if start was null, we'll be printing that linked list was empty, and we used getch so as to hold the value since we are using Turbo C++. Then if it was empty, then we'll be exiting the program. Then this node star ptr. We see this node star ptr in the top in the case of the syntax of C, as the rule of C says declare first, use later, whereas in case of C++ we can declare it anywhere in a function. Then the ptr takes the value of start. Well, we use this line so as to come to the head of the linked list. So this is the most important part of our traversal, the first part of our traversal. Then using the same condition which we used to check if the linked list was empty, which is null. If the PTR was null, which means we are either at the end of the linked list or nothing exists. Since we have checked for the empty list above, this would mean the end of our linked list. So it means till the end is not encountered, traverse the list. So checking the first condition, if PTR was not null, then we'll be printing the admission number, name and marks. You can very well see that I did not include the marks portion in case of the syntax of C. This is because the compiler of C does not support the linkage of floating points. Then comes the most important line of our syntax, which is ptr takes the value of ptr link. In case of linked list for traversal, we need this line because so as to go to the next node, we have to assign the ptr as its link. So the link portion had the address of the next node. So if we assign the address of the next node to our ptr, we'll come to the next node. So I've highlighted it in a next part, which is how the traversal is taking place. So these two lines are the most important lines, which is ptr is equal to start. That is, we are at the head and then ptr taking the value of ptr link. So when the end would come, the while condition would become true, which is ptr not equal to null. So that's how the traversal in case of linked list takes place. So I hope I was pretty clear with my topic, which is linked list, its basic concept and traversal in C and C++. We'll be covering the other operation on linked lists such as insertion, deletion, merging, etc. in our next videos. So if you like this tutorial, do subscribe us, hit the bell icon so as to get the notifications of our next video. Do visit our blog and submit your queries there. We are always happy to help you. Thank you.